Hello everyone, and today we'll be talking about Dijkstra shortest path algorithm. I'll show you the code in Java. So I'm using Eclipse IDE for this. So start real quick. Let me define the main function. Okay. Okay, so first of all, let me initialize the graph. It will be a 2D graph, so because we'll be defining the adjacency matrix for this graph, this undirected graph. So new int, and we'll be defining the values. So let me define the values real quick. Okay, so I have defined the values. Now I think we don't need this. Okay, now we'll get a clear view of it. So let me define an object for our class is equal to new shortest path. Okay, now let me make a new function in this class only. So this will be a very basic program, so and an easier one. So let me define it in the same class. So let's name it Dijkstra, and let the parameters be the graph and the source. Cool. Let me call the Dijkstra function from the main function. Let's say Dijkstra, and let's send the values as graph, and let's send 0 because 0 is our initial node. Here you can see 0 is our initial node from A, as we are considering A as our source node. Okay, what's the problem in this? The graph. What's the problem in this? A syntax error. Oh yeah, I forgot we don't send parentheses. Sorry, the angular brackets. Oh sorry, I forgot that we don't send the brackets when we are calling a function. We don't send it in the parameter. Okay, so let's go to the Dijkstra function and define a different variable distance. I will calculate about the distance of the node we have visited. Now okay, so here I have written 5 because the length of our nodes, the number of nodes are 5, 0, A, B, C, D and E. These were the 5 nodes, so I've written the length of the number of nodes as 5. So now we'll declare a boolean object, a boolean variable which will tell about if the node has been visited or not. So to make it an arrow. Okay, what's the problem in this? Maybe dimensional expression. And we'll simply pass the length. Now let me initialize the values of all these nodes as infinite, and we'll check the value of B as false. We'll take it as false because we haven't visited any node yet. So let me do it. So I write for I is equal to 0 till 5 as the number of nodes, and we'll increment them. So in Java we cannot define infinite as such, but we can do one thing. We'll define all the nodes as integer dot max value. So this is something 2 to the power 31 minus 1, some value like this. So we cannot define infinite, but this value will help us, and we will initialize our boolean, the number of or the node which I have visited, as false. Now we'll find the shortest path for all our vertices. So int, let's say count is equal to 0, count is less than 5, count plus plus. Instead of doing here only, let me make another function. Let's say its name will be, wait a second, let me make another function. Like void min distance. Sorry. Okay. Yeah, so let me store it in a variable distance, and it will call, what will it call, a boolean, and let me say distance. Okay, similarly here we write int distance of distance and boolean variable. Okay, it's showing me an error. Cannot convert from void to int. Okay, let's change this to int. Yeah. Also, one thing I missed, that the source vertex will be 0, so we can write distance of 0 as 0. Okay. As the distance of x, and the minimum and the index will be x. Yeah, and we return index as it is. Okay, so yeah, here we'll write b of I as 2, sorry, b of u as true. Sorry guys. And we'll update the values of adjacent nodes. X is less than 5, x plus plus. Oh no. What's the other? Invalid. Okay. Now we'll check if our p of u sorry, b of x, that's the variable, and the graph of x and v should not be equal to 0 . The distance of u should not be equal to integer dot max value. Done, man. And distance of u plus graph of u x should be less than distance of x. Then oh my god, what's that? Delete this token. Okay. Let me figure out this value. Okay. Not yet. Integer dot max value. So this. Okay. Yeah. Now so if it's the case, if this is the case, then I will simply write distance of x is equal to distance of u plus graph of u and x. And now let's just print this. So let's say print graph should be printing the distance and the value of x. Okay, let's make a function public void print graph. It will take the distance and value x. Okay, let's say distance from source to destination is plus now LBI plus let's print distance of I. Okay, I've written the plus sign between string and this, and Okay, so our code is complete. Wait a second. Syntax error. Okay. Okay. And our code is complete. So let's run our code. Let's go to run as Java application. Okay. Oh, it's showing me some errors. Let's see in line 4. And okay, I've placed the bracket at the wrong place. Okay, now it looks good. Oh, 47th line. Okay, shortest path. Now I think it will look fine. Okay, yeah, it works. So this was a simple code of Dijkstra. Yeah, nice. Thank you very much.